Hello everyone, and thank you for joining me in this new session on the SAP online track. My name is Femia, and today we will have an overview on how a Google Cloud makes a difference when you run SAP in the cloud. Let's have a quick look at the agenda for today. And we'll go with an introduction of cloud and then moving into the main topic, why SAP on GCP makes a difference. But as everyone don't like slide, this will be a very short slide deck. And because also as an inside track, we'll try to spend most of the time on the system and show how we can deploy an HANA system in about 20 minutes and how we can play around with HANA while we are on GCP. As we get started, just a little bit of myself. My name is Femia, as I said, and I've been playing with SAP for almost 15 years, as long time ABAP developer or in general developer, moving across different interests within the SAP ecospace, integration, mobility, analytics. And this is how I keep my passion going. I've been an SAP mentor for almost 8 years and an SAP technology ambassador while an SAP employee, and also an SAP press author with my two books, the SAP Cloud Platform Certification Guide and the SAP Conversational AI e-Byte. Today, I work at Google as an SAP solution engineer. One final note, do not miss any information at the end of this session. We'll share the detail to participate into a quiz in which you will have the chance to win a big prize. So stay tuned. So first of all, we need to address what is cloud. So we are interested in running SAP landscape in the cloud, but what is actually the cloud? Many times I ask for this question to many people, and I don't get a real answer. There is still not a clarity what cloud is. Well, cloud is simply the possibility to run your application, software, or server in data center owned and managed by a third party, in this case Google. The cloud model provides on-demand availability of compute system resources, especially data storage and computing power, without a direct active management by the user. So this is actually cloud. And I just mentioned the cloud model. So let's have a look at the most common cloud models that you may already heard of. Here we can see the different stack of items that are part of the classical IT infrastructure on-premise: networking, storage, server, and so on. And I will hope that the one on the right is not the picture of your data center. So when we talk about cloud models, the first one is the infrastructure as a service. We are delegating with this model the management of some of the stack, in this case the infrastructure, to the cloud provider that makes this component available through cloud services such as Google Compute Engine or GCE, that allows you the possibility to spin up virtual machine on demand, or Google Cloud Storage, GCS, a RESTful online file storage for storing and accessing data on Google Cloud Platform infrastructure, and many other like GKE, Google Kubernetes Engines, Cloud DNS, and so on and so forth. The next cloud model is PaaS, Platform as a Service, in which we leave the management of other pieces of the stack to focus on specific services that allows us to build application, such as APG for the API management, Google App Engine that is a platform for developing and hosting web application, or Google BigQuery, a fully managed serverless data warehouse that enables scalable, cost-effective, and fast analysis over petabyte of data. So this is PaaS. And then finally, the SaaS model, software as a service, that let the user to focus only on the usage of the application itself. Popular software as a service products that are available in Google, for example, Gmail, YouTube, Google Maps, G Suite, Search, and many others. Google has 9 products that run in a SaaS model with over 1 billion of users each. So looking at the capabilities in Google Cloud Platform, to run our SAP workload in the cloud, we leverage some of these services in different flavor. For example, we use VPN and Cloud Interconnect for external connectivity, VPC, firewall, and DNS for network services, then GCE and GKE for compute capabilities, and then we have persistent storage for block storage or Google Cloud File Storage for centralized file share, then GCS for backup, or then we have Stackdriver for monitoring and key management services or IAM, identity authentication management, for security reasons. So all these components fit together to run an SAP landscape in GCP. So what I would like to focus today is on the 5 pillars that makes GCP really unique while running SAP on the cloud. We will look on how we can upgrade easily our SAP landscape to the cloud, how we can run efficiently while in GCP, and finally how we can expand the core and innovate with a cloud platform such as Google Cloud. Let's start from the networking, and that is the backbone that makes GCP unique. This is the Google Cloud network, and Google is the only cloud provider that owns the entire network that we use to run our services. The network has low latency, high speed, and it is designed to support multiple times the today public internet traffic. It's built for the future, and it is consistently expanding. Actually, I remember that early 2020, we announced that we are going to invest over 10 billion in 2020 in US, just in US, for expanding our offices and our data centers, the data center. This is the same network that we used to use to run our SaaS services, so Gmail, YouTube, and so on, as we mentioned before. It's composed of 23 regions, with a minimum for each region of 3 zones with low latency, less than 1 millisecond latency. And this makes possible to create high available landscape that are really at the core of an enterprise ready landscape. Let's now take a closer look at the importance of having a global secure network. Most cloud providers today utilize the public internet as well as various network providers to support their data center connectivity globally. Google, in contrast, provides its own dedicated fiber network and has the most significant investment of global network of any cloud provider. So we have the possibility that to have this global provided network that allows, as mentioned before, less than 1 millisecond response time between zones within a region. But how this really works? So most cloud providers use what is so-called hot potato routing. When you're sending out traffic from their infrastructure, they offload it to the public internet as soon as possible. The traffic is a hot potato that they want off their hands as soon as possible. In contrast, Google used the cold potato routing. We keep the traffic on Google private network as long as possible and exit to the public internet at the location nearest to the end user or endpoint of presence, usually in the same city or town. That enables us to offer better reliability, better performances, and additional security. This network approach gives you the more option for system consolidation by providing better performances for off-ramp of data, as well as a simplified network configuration. We reduce the risk, as well as provide the dramatically improved performance and security for SAP environment that are deployed and running. And when I'm talking about more possibility and simplified network, here's an example of a VPC, a virtual private cloud that can span across regions and subnets that enables you to organize the workload across multiple zones. The network gives you more options to design your reliable architecture in order to support your SAP workload. But we also talk about security. And what is important about the Google Cloud Network is that it is encrypted by default, at rest and in transit. And what is important is that when you are spinning up or requesting a new storage for your workload, you have the possibility to decide which encryption key you can use. You know, who owns the key owns the data. So by default, Google encrypt the storage, but that gives you the option to use the key management service on GCP to create your own key, or actually use your own key manager on premise or other clouds and bring your own key to encrypt the storage that you need. So this is very powerful. Now we talk about the network. Now let's take a look how you move to the cloud. So there are different ways of moving to the cloud. You can consider to move just your non-production system for N+1 environment for your project line, or just having a DR in the cloud, or moving your landscape to the cloud. Then once you are in the cloud, then you're going to get advantages of the cloud like analytics and data tiering on the cloud, or maybe using some of the new services to expand the core with new and next generation application. But as I said, the path to the cloud, it's typical your specific way to move to the cloud. So you can decide to move first dev and QA, then DR, and finally production. But then you have a different strategy, so you want to start first with DR and then moving with the other system. The idea is that while in GCP you have the freedom and the complete flexibility to move your SAP workload to the cloud as you consider the best way and the best approach based on your specific needs. And this is very important to understand. And then a transition to the cloud can mean a variety of different approaches for an SAP landscape. Some customers look for an initial cloud transition as a move or lift and shift strategy. In this situation, you purely want to take the existing SAP application landscape and move directly to the cloud. In a lot of cases, however, this strategy often requires some degrees of OS or DB or other minimal technical migration. In this case, customer will leverage SAP and third-party tools to help those technical upgrades where required. Lastly, there is the scenario where you transition to cloud and also you include a complete technical and functional upgrade. This is an example of S/4HANA transformation, in which case the move to the cloud not only may include technical upgrade, but also additional transformation complexity, as may be typical of SAP landscape that are merge, harmonize, or consolidate. But to move to the cloud, what we provide is a very quick way to transition to the cloud with Google Managed Deployment Script that allows you to spin up SAP environment with just one click. For example, we have those templates available and are basically available to anyone publicly that you can download and deploy as they are through the deployment manager. Now, if you have specific requirement or you want to customize, these are open, so you can basically change it, tweak it, and adjust based on your specific requirement. And why it's important to automate? Because you can deploy system in less than 30 minutes. But when I say system, it's an entire landscape with HA, for example, in the case of the HANA. And we will see in a few seconds this demo. But also the idea that you can automate and you can also utilize custom images that are specifically for your needs instead of using standard version of operative system or other software. And as I said, you can customize, adjust, enhance those deployment scripts as you like, as you need. We talked how you move to the cloud, how you leverage the network, but now when you are in the network, how you run your SAP. First of all, this is very important. We used to have this decision at the beginning of our implementation project. Let's size up our HANA box or SAP box for supporting us for the next 3 years. And what you're doing, you are committing today to the size that you will need based on an estimation in the next for the next 3 years. In GCP, what you can do, you can scale as you need, scale as you grow. So you can commit on year one now on what you are actually using on your SAP landscape, and then sizing the landscape based on the evolution of this SAP landscape. So instead of, as we said here, saving, it's basically cost avoidance, because you don't have to pay for that computational power because you don't actually need that power. But what it brings along this grow as you go is that while you are growing, next year you will upgrade your VM to the bigger box or another box, but you will get also the advantages of the technology improvements that have been done in these 12 months. So for example, let's say that you are on a Broadwell and now it's Cascade Lake, you will get Cascade Lake. And this is all included into your GCP platform. You don't have to pay more for better technology. But what is also important is that you grow as you go, but you want probably resize as you run. So we provide in the dashboard suggestion that you can accept, but basically based on the consumption and based on the actual workload that has been loaded into SAP in the previous period, we will suggest to you what could be the best architecture to run and save money. What is important here is that GCP is the only cloud provider that allows you to have custom machine. When I say custom, you can decide exactly the number of CPU or the gigabyte of memory that you want to that specific machine. So, great advantage and way of sizing and optimize your SAP workload day by day. So we talk about we upgrade, how we grow, but now what we want to do is how we can reduce downtime, how we can secure business continuity while we are in the cloud. Very briefly, we have 3 levels of high availability. One on the infrastructure layer, and this is completely managed by Google. So you don't have to do anything to make sure that your infrastructure is highly available. And we offer a no cost, no configuration, live migration, and host auto restart on top of your infrastructure. Then you go into the database layer. And so there are different ways that you can provide high availability, in this case for a HANA system, based on a scale up or a scale out system with synchronous HANA replication or with HANA standby node. And then finally on the application layer with Linux clustering for your central instances. So the ability to have also the application layer in an high availability landscape. And in this picture, I just wanted to summarize how a landscape, an SAP landscape, look like on GCP. You have 2 regions. One primary region that is called region A in this case is the one that runs your production system, and region C is where you run your DR. And then in the region A you have 2 zones where you implement the HA again with HANA synchronous replication. And then you have storages that are spanning across region that are used for NFS, file system, and backups. So this is a typical SAP landscape. Now, is this the only landscape? No. So based on your requirement RPO, RTO, we can optimize and reducing the number of system or improving the amount of computational power that you require to have a successful HA and DR on top of your SAP landscape. Then we mentioned before live migration, and live migration is one of the most interesting technology that only GCP can provide to the cloud. So live migration allows you to basically have no downtime while we are performing any infrastructure maintenance or hardware upgrade. So you don't experience any downtime. And we will have a demo on this. We will see how we can run SAP HANA and the process in there without disrupting the application layer while we are performing this migration. And this is unique because we are not going to call you and say you need to shut down because we need to change memory, or we need to do something, or you have to do any manual activity to basically perform an infrastructure maintenance. This is very powerful. And one other topic related to the operation related to SAP is Stackdriver. Stackdriver is the default logging mechanism service that we can use in GCP that is enabled by default to all the services that we have, but can be enhanced using the API to integrate with external system, but also to integrate with your solution manager. So the combination of solution manager from an application side and Stackdriver from an infrastructure side can provide you an overall and global vision of your SAP landscape in real time. So we talk how we upgrade, how we run, and then while you are in the cloud, how you innovate. How you innovate and keeping the core clean. One example could be utilize BigQuery, the petabyte scale database in the cloud, data warehouse actually, that provides you the capability of integrating different data sources from SAP landscape, for example, SAP HANA in this case, with heads data, geospatial data, social media data, combine all together in this data warehouse in the cloud and apply machine learning or exposing API or creating dashboard on top of this BigQuery. And as I said this is a petabyte scale with the P. Another innovation could be the utilization of an API management like Apigee, connecting your SAP information that are coming out with the OData with third-party tools and provide an API layer, a agnostic API layer that can expose in an API flavor this information securely to supplier, vendors, and other applications. And finally is the innovation itself. So you want to innovate on top of SAP, but you want to get also the most and the greatest technologies around there. So using Kubernetes to create application on top of your core. That changed the game completely. The ability to keep the core clean and expanding the core with new outstanding application with easy management, scalability that you can have in a Kubernetes environment. As I said, very few slides, very quickly. I don't want to be a sales guy or a marketing guy. You know, I'm a developer. So it's time to go into the demo time. And we will enjoy this demo in 4 main steps. Step 1, as you can see, we will basically use one of the deployment manager that we spoke about earlier before to deploy a HANA single node HA environment. So basically we will deploy two HANA instances in two different regions in our US, in two different zones in our US Central region. So US Central 1B and US Central 1F. And we will basically configure through the deployment manager a HANA cluster with SUSE pacemaker that will make sure that we'll have a HA environment set in place. And those databases, those HANA databases will be set up with HANA system replication. All of these will be tracked down through Stackdriver. And what we also have, we have a Windows instance, a jump server that we will use to interact with our machine with HANA Studio. So let's get started. So let me just go into my Google Cloud Platform. So this is how the homepage of Google Cloud Platform looks like, with all the details that I need to know for quick overview. And what we will do, basically, I will use the Cloud Shell. So Cloud Shell is a very powerful tool that we have in Google Cloud Platform that allows you to basically interact with the terminal look and feel shell to our GCP. So we can run commands and type in statement in here. It's very helpful, very useful to run with. So what I have here, I have one command that will deploy. We create a deployment manager using one of the deployment script that we talk about. I have this deployment script. So what it's doing now is creating a deployment package, and let's have a look at the deployment package that has been deployed into our deployment manager that basically will set up this environment that we spoke about. Now let's give a few seconds to have the deployment script up and running, because what I would like to do is just spend some time to look at the actual script, at the actual deployment template that we are using here. So in a few seconds we should see this deployment script deploy into the GCP console. So the deployment script has been deployed. As you can see here, everything is completed. So if I go basically my compute engine, I will see in a few seconds that two Linux box has already been deployed into my GCP platform. What is interesting here is basically those Linux box are already up and running, and I can technically connect through SSH to this machine. What is happening now is downloading the HANA binaries and start the installation of HANA. So while we get there, let me just have a look at the deployment script. So let me just go and open one of these scripts. This is the one that we just used, and basically is and let me just enlarge a little bit. It's a script that invokes a Python script with several parameters. So if I want to deploy my own instance of HANA, I can just simply change these parameters if I want to use the template as it is. Otherwise, I can just go and look at the template script here, for example, and I can download this YAML file from Python script and start tweaking around and change it as I need, where I need. So let me just close. Perfect. And let me go back here. So what is happening here? And let's have a look at these logs. And let me just log in here. Log viewer. I can see what is actually happening in the system with the deployment manager. So the deployment manager, and we'll just look in here, is basically, in this case, already started the installation of some of the packages that I need to install HANA. Here we go. 17 minutes has passed since we started the deployment, And now primary HANA has been deployed, is attached to the IP that we configure, and actually the secondary HANA is being configured the same way, and the replication and the pacemaker has been set up correctly between the two instances. So very quickly and basically with no manual effort from our side to have this up and running. So right now what we have is the two instances with the pacemaker with an HANA cluster that is making sure that there is an HA environment in place with HANA synchronization between the two. So what we want to see now on step 2 is we want to see the configuration of pacemaker, then we want to simulate a failover, and we want to see how the HA will kick into and make sure that there is continuity and high availability on this cluster if something happens to one of the primary instance. So let's look at the first of all at the HANA system. So let me go into my jump server here. I already have my Windows box here with my HANA Studio installed, and what I will do, I will just connect to my database. So let me just try to log on to my database, and I'm connected to my database. So if I click on the system DB status and the overview, I can see that I have, in this case, is a 50 gigabyte machine due to the limitation of my resources in my personal instance. I just deployed a 50 gigabyte, but for the codes, it's more than enough. And what I can see, I can check the landscape. So I can see that there is a primary HANA up and running. All the services are red. There is a system replication ongoing, synchronous system replication between the primary and the secondary HANA, and I can check also the OST is working, and so nothing wrong here. So from a HANA Studio perspective, everything looks perfect. Wonderful. So let me go back and let me go into the actual console, into the terminal of my Linux box. So what I would like to do is using the embedded SSH client that I have on GCP to connect to my HANA box. So we don't need anything here. We can use all the tools that are already embedded into the GCP platform. So right now it's just connecting to the system, sharing all the everything. So I'm connected to my system. So what I will do, I will just enhance my permission here, and first of all, I want to see how the configuration of the disk has been done. So basically, based on the system, the script, the deployment script was calculating the right spaces that I need for this specific deployment. Now, what I would like to do is also look at the pacemaker and just make sure that everything is in place. So as we saw in the HANA Studio, we have a cluster, a HANA cluster with a primary and secondary HANA set up. And we see that the master is the primary HANA, the slave the secondary HANA, and there is basically a cluster set up between the two instances. Now, in order to simulate now a failover, I will just do the bad guy and I will simulate the disconnection of the Ethernet in the primary HANA. So let me just go here and let me just do this. ifconfig 8080 down. So basically I disconnected my box, my Ethernet cable. Let me close this one. Let me just not go in full screen, but just having this one here. So what I can see now from the console, I can see that from the operation, the system will identify that there is a problem with the Ethernet of this machine. So let's wait a few seconds to have these monitored here. Here we go. We see that there was a problem with the Ethernet, and actually the auto restart is basically resetting this instance and basically rebooting the primary HANA instance in order to have this back running due to the error. But what I can see also from the logs, I can also see that from a log overview, now I can see that Pacemaker realized that there was an issue with primary HANA. So basically, it just, and we saw live that it just switched between the primary HANA to the secondary HANA. So now the secondary HANA is the new HANA database connected to my virtual AP that I configure into my deployment script. If I go back to my jump server here, and if I just do a refresh, from an HANA Studio perspective, nothing changed. So I'm connected, still connected. I'm still waiting the HANA system replication to start because the HANA primary instance is rebooting. Probably now it's back in place. So the primary instance has been rebooted. But then from a landscape, I was running on the primary HANA. Now it's a refresh. I can see that now I'm running on a secondary HANA system. The host, as I said, previously was primary HANA, is now is my secondary HANA. What happens to the system replication? We already refreshed, so now the system replication is going from the secondary HANA to my primary HANA. So this is as easy as that. So we were able to simulate failover from the primary HANA to the secondary HANA, and without affecting the operation of my HANA Studio. Now, third step of our demo. What we would like to do is to make sure that we have our system scale up. So first of all, we will suspend Pacemaker on the primary HANA. We will resize the HANA system. We will restore the Pacemaker, and we will restart HANA. So basically, with this simple step, and without affecting the operation into my HANA Studio, because my user can still work on the HANA Studio, I can resize and give more memory to my HANA box and do a scale up of my system, as we discussed it before. So let me go in my GCP console. Let me go back in the compute engine, and let me close the previous open SSH terminal, and let me open again another terminal to my primary HANA. Just enlarge a little bit. So as before, we are connecting to our primary HANA, and we are good to go. So what I would like to do, first of all, as I said, let's set up the Pacemaker as in maintenance mode. So let me go back with my privileges, and let me just go here and let me configure the Pacemaker. So property, just make sure that I'm not doing any typo, and then maintenance mode equal true. So now my maintenance is set up. So let me go and check the status. Let me just check that this says kicking into. As we can see here, resource management is now disabled. So basically this has been stopped, and I'm able to quickly operate on my primary instance without kicking any failover because something is happening to one of the two machines. So let's go, as I said, and let's stop the HANA database. So my instance is called GCP and then HDB. So let me connect with the GCP H admin. Sorry. And now what I will do, I will just do HDB stop. So let me stop my HANA instance here on the primary one. And as we can see here on my HANA console, I will see that basically my HANA system is up and running. So the HANA stopped. So let me just exit from here. Perfect. And now I can gracefully stop also my primary instance. So my primary instance is now stopping. Okay. What's important to notice is that from an HANA Studio perspective, I'm still connected to my HANA database, my secondary instance, because the primary instance is the one that is now the secondary instance set up in the system. So if I look at the system replication, I can see that this is not working because I stopped my primary instance. So my primary HANA is stopped, and what I will do, I will just go into the primary HANA and I'll do a scale up. How complicated is to do a scale up? Well, it's so easy. So what we deployed previously was an N1 standard 16 with 60 gigabyte. What I would like to do is just increase and double the memory of my HANA database. So I will switch to N1 standard 32 with 120 gigabyte. So I just switched. I just had 50%. I doubled actually the memory of my HANA box. I will just save my VM instance, and once this is done, I will just restart my HANA instance. Let me restart my HANA instance, and let's wait a few seconds to have this back in place. Primary HANA is started, and what I can do, I can reconnect through SSH to my primary HANA. Let me go here. Let me just open again my terminal. And we'll do a few steps here, as I said. We will restart our HANA instance, making sure that this is up and running. And we will re-enable the pacemaker HANA clustering. And once we have done this, we will check, we will basically refail over from the secondary one. So let's wait a second, or 22 is still not listening to us. Here we go. We are connected to our primary instance. So let me just reconnect as a GCP admin. And let me just add the password of the user. Here we go. And let me just make sure that our HANA instance will starting. Okay, HANA started. So what we said we have to do is to basically sudo minus, making sure that we reconfigure our CRM, our pacemaker, and making sure that everything is set up. Configure property maintenance mode equal false. So now if we done CRM status, we can see that our pacemaker is starting to taking place. Let's wait. Everything is green. So our pacemaker is back in service and we are good to go. So now let me just stay with the terminal here. What I will do, as I said, I will resimulate a failover, this time from the secondary HANA. So let me connect to my secondary HANA instance, and let me just do the same on the secondary HANA. Basically disconnect the Ethernet cable and making sure that the pacemaker will switch back to the primary instance. So let me just go quickly here. Config 80 down. Boom. So secondary HANA is that. So let me just check here the logs to making sure that pacemaker as before. Notice the issue, and basically it will check the switch from one HANA system to the other. So we should see in a few seconds the notification from pacemaker that primary HANA is taking over secondary HANA and the VIP has been attached to our primary instance. Here we go. The secondary HANA is being reset. We're resetting everything, and the primary HANA is taking over on the secondary HANA. So let's just go here, just removing the IP connection, and now primary HANA should be connected to our virtual IP. I'll just wait for the confirmation right here. Here we go. Primary HANA is connected to our primary IP. Now, if I go back to my HANA Studio and I will check the services, now I should see primary HANA here. So let me just refresh. Here we go. Primary HANA is now our database where we are connected. This is the host. And what is interesting here is now we were 50 gigabyte before. If I refresh, you see that I basically double up the memory of my HANA database. So I was able to scale up basically without doing anything crazy. I was just changing the machine type and I was just rebooting everything. Now secondary HANA is restarting. So we should see in a second that also the synchronous replication has been restored, and secondary HANA is now doing the replication. It's just receiving the replication from the primary HANA. Very interesting and great. Now, final step. We want to simulate a live migration. Live migration, to do so, let me just connect to my tenant. So let me log off from here and let me relog on my tenant database, and let me open SQL console. And what I will do in this HANA instance, I'll basically copy and paste, and let me just copy from here, from my notes, a script that I will use for simulating a process that is running on the system. Oh, this is Windows, so it's Control V. So basically, I create a procedure that basically writes a new entry into a table that is called system timestamp. Every 5 seconds. Every 5 seconds, we write a record into this table. This is for making sure that we can track that basically there is no disruption on our application side of any operation while we are running the live migration. So let me just copy this because I will need in a few seconds, and let me just deploy the store procedure. So my store procedure is deployed and activated, and let me just open another SQL console. And what I will do, I will just call the store procedure that I just created. I will use the default parameters that I have. So let me enlarge a little bit all the notification and everything here. And let me just have this up and running. So my procedure is running and is writing a record every 5 seconds in that table. What I will do now, in the meantime that is running, I will go into my compute engine to make sure that I have all the right parameters. And from my gcloud console, gcloud shell, I will just execute a live migration. So let me just go here and just do gcloud compute instances simulate maintenance event. Now I need to say on which instance I want to simulate this, and this will be my primary HANA database. And then I have to specify in which zone I want to have this maintenance. So this is because I'm simulating and I'm basically forcing live migration. You as a user, or we as a user, will never simulate or trigger a live event, a live migration. This is more something that the infrastructure will do. The infrastructure maintenance will do when they have to do something. So now I'll simulate a maintenance event, and so the simulation of the maintenance event is basically moving this VM from one hardware physical location to another, because we need to do hardware maintenance on that specific machine where it's running now. So what we see here is that in a few minutes, basically, the machine will be migrated into another hardware. Here we go. The instance has been migrated into another instance. As you can see, in a couple of minutes, the live migration was able to find another hardware where to put this VM, and basically making sure that everything is running perfectly. So everything is set up, and I can see also from my VM, let me just go here into the VM instances, that if I go into the details, my VM is still up and running. Nothing happened to my VM whatsoever. But now what I would like to do is to switch back to my HANA procedure. This is still running. So let me just do this, and let me just open another console, and let me just do a select star. I know we should not do the select star, but this is one field. And the database table is system timestamp order by timestamp descending. So if I run this SQL query, I can see that the system was writing every 5 seconds a record since we started. So every 5 seconds I have a record written. And as you can see, there was no disruption, also because this procedure is still going. Actually, probably it's finishing right now. So it's still going, and every 5 seconds was able to write into our HANA database while we were doing our live migration. And actually, if we check the time, the exact time that the live migration was performed and the writings into the database, we should see here it was 5:14 and 21 seconds. So this is, I have to change 7 hours time zone. So basically this is 5:21. Here we go. It was in this time frame. So after 5 seconds he was writing something, and this is where exactly the live migration took place. but from an HANA perspective, I had no experience. Nothing was basically, from an application standpoint, was triggered. So no failover, no errors, and anything. My procedure actually completed right now, just executed for 7 minutes, and it was able to complete and write down all the rows that I needed. And actually, what I can do here, I can also go here and just basically say uptime. Uptime, I can see that this system is running for 16 minutes. So basically, when we restarted the machine after the failover, and it was not affected by this live migration. I think that's end of step 4. And as I said, um, we saw today a very interesting aspect why SAP on GCP makes difference and enables you to do things that you were not able to do before, and doing the same things that you were doing before in a better way. Now, as you can see here, I thank you for the attention, and there is this small quiz. It's through a Google form. So, and the winner of this contest that will get the fastest and the highest score will get a free copy of my digital e-buy SAP Conversational AI. Thank you again for listening and enjoy the SAP online track. Bye.